In this video, we will see about spanning tree. Actually, spanning tree is a subset of a graph. Let us take one example graph. So this graph contains 6 vertices and 6 edges. So first I will explain with a simple graph without any cycle. So here this graph don't have any cycle and the number of edges and the number of vertices are same. A graph can be represented using a set that is vertex and edge. So vertex is a set which contains all the vertices in the graph, and edge is the set which contains all the edges in the graph. So in this given graph, the vertex set contains 6 vertices and edge contains 6 edges. And now a spanning tree is a tree. I already told you this is a subset of this given graph. So this graph has 2 sets. One is this vertex set and another one is this edge set. So now this spanning tree should have spanning tree is a subset of both vertex and edge, or it is subset of either vertex or edge. Actually, the spanning tree contains all the vertices in the graph, but it should contains a subset of its edges. So just recall your tree properties. Since this spanning tree should be created from the given graph. So this graph contains 6 edges, and the spanning tree should also contains all the edges. So all the vertices. So number of vertex in the spanning tree is 5. So this is the number of vertices in the this is 6. So number of vertices in the spanning tree should be 6. So from the properties of tree, if a tree contains n number of vertices or n number of nodes, if the number of nodes in the tree is n means, then the number of edges in the tree should be n minus 1. So that is the property of any tree. Now from this graph we need to find a subset of this graph which contains all the number of vertices but a subset of edges. So by default, if the number of vertices is v means, so the spanning tree should contains v minus 1 edges. So in this example, so number of vertices is 6. So the spanning tree should contains 5 edges. So n minus 1. This is the common property of any spanning tree. So this example is without that graph without cycle. So we can form multiple spanning tree from the given graph with this property that spanning tree should contains all the vertices and edges is number of vertices minus 1. So for this we can form one possible spanning tree is, so I just include all the edges from 1 to 6. Just I am discard this edge. So this is one possible spanning tree. So this is a tree. There is no cycle, and there are 6 number of vertices and only 5 number of edges. So another possible means we can. So here I just remove this edge. It will give you one spanning tree. Or otherwise, another possible is we can remove this particular edge. So this is also a spanning tree. So in this way we can able to form multiple spanning trees of a given graph. Okay, so what is the number of spanning trees can be formed for this kind of graphs without cycles? So our problem is we need to find a subset of these edges. So we have, in this example, we have 6 number of edges, and we need to select 5 number of edges from this 6 edges. So there are how many possible ways 5 edges can be selected from 6 edges? That is 6C5. So that is combination of 5 elements from a set of 6 elements. So this is the number of spanning trees can be formed with number of vertices 6 and no cycle in the graph, and the graph is fully connected. So 6C5. So this number of spanning tree can be formed for this given graph. So suppose if the number of vertices in this graph, a graph without cycle and the graph fully connected, is NC n minus 1. Suppose if the graph contains a cycle, for example, the same graph, if the graph is the same graph, now I include one more edge. So this edge, now this edge form a cycle. So in this case, for the same graph, we need to form a spanning tree. So this graph contains 6 vertices. So that spanning tree should contains 5 edges. So as usual, the same n. Sorry, for this example, this will be 6C5, and one edge. They create 2 cycles. From this number of combinations, we need to subtract the number of cycles that has been formed. So actually, in general, if a graph contains a cycle and number of vertices is V, sorry, number of vertex, the number of vertices is V, number of edges is E, and from that we need to select V minus 1 edges. So from this number of edges, we need to select V minus 1 edges, because our tree contains V number of vertices minus number of cycles. So number of cycles. So this is the general formula for calculating number of spanning trees in a graph with cycle, and this is the formula, that is number of edges count C, number of vertex minus 1. So this is the actual formula for graph without any cycle and which is fully connected. Thank you.